Hello everyone, welcome back to my YouTube channel. My name is Saniya Sulthana. Today let us discuss about applications of partial derivatives. Let's go through a introduction. A partial derivatives are used to analyze how a function changes with respect to one of its variables while keeping others constant. They play an important role in the multiple variables calculus, enabling to study the functions with multiple input dimensions. Taylor series expands a function into infinite sums of terms, providing an approximation around a specific point. It involves the derivative of a function at that point and the variable for approximating the complex numbers, solving differential equations, and understanding the local behavior. Next, we will go through a partial derivative definitions and the formula. Definitions: the partial derivative is used in the vector calculus and the differential geometry. In mathematics, sometimes the function depends on two or more variables. Here, the derivatives converts into a partial derivative since the function depends on several variables. In this article, we will learn about the definition of partial derivatives, their formula, partial derivatives rules such as chain rule, product rule, quotient rule with more solved examples. Formula: if f of x is a function where f partially depends on x and y, and if differentiate of x and y, then the derivatives are called the partial derivatives of f. The formula of partial derivative of f with respect to x taking y as a constant is given by f of x dou f divided by dou x limits x into f x plus h y minus f of x divided by h. It is a partial derivative formula. Next, we'll go through applications of partial derivatives. In that, we'll go through a physics and engineering. In mechanics, the partial derivatives helps to analyze the rate of change in a multiple variable system such as velocity, acceleration in different direction. They're also important in the fields like dynamics and other theorodynamics. And next, it is used in the computer science. In the mechanics, learning about the optimizing the algorithm, partial derivatives are employed for a gradient disaster as a key. It is a key technique to minimizing the functions and training the models. And it is used as a environment it is used in the environmental science. The partial derivatives are applied in a environmental models to understand the impact of various factors of ecosystems and the natural process. Next one is science. The partial derivatives are applied in an environmental modeling to understand the impact of various factors on the ecosystem and natural process. Next is operation researchers. The partial derivatives are the employed in optimizing the problems to find the most efficient solution in the areas like logistics, transportation, and resource accumulations. Next is strategies. In strategical analysis, the partial derivatives are used in the analysis to assess the impact on the individual variable on the model's output while holding their constant. Chemistry. In chemical kinetics, the thermodynamics partial derivatives are used to study how the different factors influence the chemical reactions and equilibrium. Next, our topic is Taylor series. Let's go briefly definition of Taylor series. A Taylor series is a polynomial or a functions in or a indefinite sum of terms. Each successive term will have a greater exponent or a high degree than the pretending term. formula is f of x equals f of a plus f dash a, x minus a plus f dash a divided by 2 factorial x minus a square plus x to the power of 3a divided by 3 factorial x minus 3 whole power q plus so on till it will continue till end. Next, we'll go through applications of Taylor series. First one is function of approximation. Approximation, in that Taylor series is a commonly used to approximate the complex function with the simpler one. Engineers often use a Taylor approximation to simplify normal non-linear equations for easier analysis. Error estimation, it is used to identify the error estimation Tyler series at a certain order. Engineer can estimate the error introduction in the approximation. This is important in numerical method, ensuring that the calculated value within the expectable range of occur. Control system, it is used in the control system too. The Taylor series can be applied in a control system to linearize the non-linear equation around the operating points, simplifying control system designs. In applications only we will use in the physics, mechanics. In physics, the Taylor series used to approximate the behavior of the system. In classical mechanics, for sustains the predicting the motion of bodies. Next one is thermodynamics. In thermodynamics, the Taylor series is used to linearize the equations that describes to behavior of the gases and fluids, facilitating the analysis and productions. Next one is quantum mechanics. In quantum mechanics, the Taylor series is employed to approximation wave functions and to study the behavior of particle in different potentials. Next one is optimization of logarithms. Taylor series play a role in a optimization logarithm by approximating the objective functions, adding or finding a optical solution. It is in Next one is infinite multiple analysis. It is also called as FEA. Engineers are used Taylor series in FEA to approximate and analysis the behavior of structures and the multiples around the various conditions. Conclusion, we are at the conclusion. The partial derivatives is a important to understand how a function changes with respect to specific variable. A Taylor series expands a function around a point, providing a polynomial approximation. This is a in variable in